Hello all, welcome to my channel. We are in the subject of operation research. In this video, I will explain the various forms of linear programming problem. So let's start. A linear programming problem may be expressed in different forms. Like it can be a general form of LP or linear programming. It can be a canonical form or it can be standard form. So all these forms have its own importance and its own application. So LP problem can be expressed in any of these forms depending on the way in which it is to be solved. First, we will see the general form of a LP problem. Any general form would look something like this. Now, we all know what do you mean by objective function, constraint and non-negativity restrictions. So what is different here? Here, a general form may be of maximization type or minimization type. And it can have less than or equal to constraint, it can have greater than or equal to constraint, or it can have equal to type of constraint. So there is no restriction on the type of constraint that can be in the general form of a LP, and it can be a maximization type or a minimization type of sum. So you can see in general, a LP problem in general form is represented like this. Maximize or minimize j is equal to C1x1 plus C2x2 plus C3x3 and so on, where C1, C2, C3 are the coefficient of the decision variables in the objective function, and these are the constraints A11 x1 plus A12 x2 and so on. Second constraint is A21 x1, A22 x2 and so on, and the last constraint will be A m1 x1 plus A m2 x2 and so on. And there can be inequality less than equal to type or greater than equal to type or equal to type, and the right hand side would be represented by b1, b2, b3. This is the general form of any LP problem. The features of general form are the objective function can be maximized type or minimized type. The constraints can be of the form inequality less than or greater than or equality, but at one time only one constraint would be there, and the non-negativity constraint should also be present and should always be of the greater than or equal to type. Then second form is canonical form of a LP problem. You can see in the canonical form there is slight difference here. In general form we will see maximize, minimize. Here we have only maximize, and since we have maximize here, all the constraints should be less than or equal to type only. This canonical form is generally used when we are using dual simplex type of method. So it can be represented in this way, as we saw the general form, where we have maximize type only and less than equal to type constraint only. The features of canonical form are the objective function should be of maximization type only, the constraint should be of less than or equal to form only, and non-negativity constraint should be greater than or equal to type only. The third form which is commonly used and the form which is used to solve by using simplex method is standard form of a LP problem. Now in the standard form we can have maximize or minimize. We can have maximize or minimize, and here we will not have any inequality. It will always be in terms of equation. So we can see there are three equations, there are no inequalities in the standard form. So standard form would look like this. If you want to represent it in terms of variables, it will look something like this. The point to be noted here is in standard form we can have maximize, minimize, but we will have only equations. And what are the characteristics of standard form? The characteristics of standard form are the objective function can be maximization or minimization type. All constraints should be of the form of equality only, and non-negativity constraint should be of greater than or equal to type only. So if you see all these three forms, general form, canonical form and standard form has its application, we will use standard form to solve a LP problem by using simplex method. And there is one more addition in the standard form, the right hand side of the constraint should always be positive. So we have already seen in the graphical method the right hand side of the constraint should be positive. Now we'll go through few numericals to understand the standard form. The first one is to convert the given LP problem in a standard form. Now this is a given LP problem. Now since we are asked to convert it into standard form, what we want in standard form? Number one, the objective function should be either maximize or minimize. It is maximize, that's not an issue. Right hand side should be positive. All the right hand side terms are positive, that's not an issue. But there are inequalities. So our work here is to remove this inequality and convert it into equalities. So how do we convert it into equalities? We have seen in the earlier video that this left hand side is less as compared to right hand side, so we'll add something. In the second constant, the left hand side is more than the right hand side, so it subtracts something. And in the third constant, the left hand side is less than the right hand side, so we'll add something. The thing which we are adding is called as slack, and the thing which we are subtracting is called as surplus variable. So the first equation will become, constant will become 12x1 plus 11x2 plus 16x3 as it is plus s1, and this will be equal to 22. In the second, we will have this should be minus s2, this should be minus s2 equal to 41. There is a correction here, and the third will be plus s3 equal to 66. And of course, x1, x2, x3, and the three surplus or slack variables s1, s2, s3 should also be greater than or equal to 0. Let us see the second problem. You have to convert the given problem into standard form. So if you see here, we want either maximize or minimize. We have minimize, no issue with this. The inequality constraint has to be converted into equality, that we know how to do now. But there is a constraint where we have negative sign in the right hand side. So this we will have to change. So this will be our first step, to change the right hand side of constraint to positive, that is to plus 60. So how will we do that? We'll multiply the constraint by minus 1. When we multiply the entire constraint by minus 1, we'll get it like this. Instead of x1 plus 4x2 minus 3x3 is greater than or equal to minus 60, we get minus x1 plus 4x2 plus 3x3 is less than or equal to 60. Now all the constraints are of less than or equal to type, so we have to add only slack variables, no surplus variables are needed. And we'll add s1 in the first constraint, s2 in the second constraint, x3 in the second constraint, and we'll convert all these inequalities into equality. And of course, s1, s2, s3, x1, x2, x3 has to be greater than or equal to 0. Let's move on to the third problem. And here also we have to convert it into standard form. What's the difference here? Here we find that in the first equation is equation. There is no inequality here. It is just an equation. So it is satisfying the standard form condition that it should be an equation. It is equation, right hand side is positive, so no issue with the first constraint. Second constraint is having right hand side as negative, so this will change to positive by multiplying the entire constraint by minus 1. And the third constraint is less than or equal to type, so we'll add one slack variable here in the third constraint. So we will first convert the right hand side of constraint 2 from minus 6 to plus 6 by multiplying it by minus 1, and this equal to sign will remain as it is. So we will add slack and surplus variable. So there is no surplus variable to be added, only slack variable is to be added in the first constraint. There is no need to make any change. In the second constraint, there is no need to make any change. From here, we have already made the change here. And in the third constraint, we have just added a slack variable s1. And of course, x1, x2, x3 and s1 should all be greater than or equal to 0. So this is the standard form of the given LP problem. Now, we can see one more sum here. And here, what is the new thing added? The new thing added here is x3 is unrestricted in sign. It is saying that there is no restriction to the sign of x3. It means that x3 can have any sign, positive or negative. So this is not accepted to us. So we need to change this. So how do we change that? We'll explain the unrestricted constraint as non-negativity. How will we do that? Now x3 is unrestricted in sign, but x3 dash and x3 dash, the two constraints, the two variables that we are introducing will be greater than or equal to 0. And we are writing x3 as x3 dash minus x3 double dash, where this x3 dash and x3 double dash both will be greater than or equal to 0. both will be greater than or equal to 0. So in this first objective function, we'll replace x3 by x3 dash minus x3 double dash. So you can see it here. Objective function is replaced as x3 dash minus x3 double dash. Even in the constraints, we'll replace x3 dash, we'll replace x3 by x3 dash and x3 double dash. So everywhere we have replaced x3 by x3 dash minus x3 double dash. So we have x1, x2, x3 dash and x3 double dash, all are greater than or equal to 0. Now this is a simple sum where we have constraint first less than or equal to type, second greater than or equal to type, and third less than or equal to type. We have to just add the slack and surplus variable. So that we'll do here, add slack or surplus variable. So in the first case, we'll add slack variable. In the second case, we'll add surplus variable, or I can put it like this, we'll subtract minus s2. And in the third constraint, we'll add slack variable s3. And the given equation changes like this, where we have x1, x2, x3 dash, x3 double dash instead of x3, and s1, s2, s3 all greater than or equal to 0. So we'll meet in the next topic, which is simplex method for solving the linear programming problem. Thank you.